And Mark. So this is another video of mine, and basically this is a look at another program that I'm doing. It's entirely different. It's for my math paper, IB Math. And basically the paper is looking at applied computer science to Raymond's hypothesis, and that looks at how you can find primes faster when they are larger, and how they can take small and somewhat large prime numbers, multiplying them, and you find if the produced number is prime or not. It's kind of how it was referenced in the show Numbers. So that's out of the way. And this currently is my program that is, well, kind of long, as you can see, and a lot of stuff's been commented out. It's because I realized it wasn't useful, or whatever, didn't work, and you can ignore this whole section down here. Basically, I'll explain quickly. This is my main method, where basically I'm just referencing to a number, the method, which is an int. I don't have to put any parameters, thankfully, made it nice and simple. In Eclipse, I have to do this, where I make a scanner, and I get a number, and I say, okay, I want to prime this number blank, and then I throw my input in, and it gives it out. And then it goes to the other method called isPrime. I throw that value in, and when I throw it in, it looks at the first most obvious prime, besides 1, 2. And it goes, hey, is 2 less than the number? If yes, go on and divide divide that number by 2, find the remainder, and set that remainder value to this variable called result. Then this is another method right here I'm going to explain in a second, and it takes that result value, puts it into an if statement, and it says, hey, if that remainder is nothing, print it so I know. And then that basically is telling me right there, this is a factor of this number. So let me show you what I mean. Let's run this, right? Prime number, let's put in 11. 11 returns nothing because it's a prime number. So proves that it works there. Let's put another number like 14. Okay, get 2 and 7. Two smaller prime numbers. When multiplied, produce this composite number that's even. It's 14. Try that again, you get, say, number is 12. Okay, now notice, you have 2, 3, 4, and 6. 4 and 6 are composite numbers comprised of 2's and 3's. Specifically, the 4, 2 squared, and 6 is 2 times 3. Now, I want to try and figure out how in the world they get absolute primes. Absolute primes, in this case, would basically mean just the 2 and 3. Those would be the absolute primes for the composite number 12. Now, there's a trick, and a reason why I did this was because there's this thing called a palindrome number, which looks like this, starting very small. 121 produces 11, right? Meaning 121 is not a prime number, but you can find the factors of it, right? And the next palindrome number would be something like 1, 2, 3, 2, 1. Okay, and palindrome numbers, if you haven't already noticed through the pattern here, is that they look the same forward as they do backwards. So what I did right there is I just went 11, 1, 2, 1, 1, 2, 3, 2, 1. Next would be 1, 2, 3, 4, 3, 2, 1, and so on. Now eventually this stops after like the 9th term in the sequence, and it's called the Demlow number. Now the Demlow number is something basically where it's some fancy number sequence and it shows that, and it basically is a proof mathematically. So moving on, that's that, and looking at this, you'll notice that these are a bunch of factors that make up the number 1, 2, 3, 2, 1. Okay, and notice how it's not including this number in its own factor, as its own factor. Now, to show this, you can't input anything. Once it's factored a number, you can't do it again. Now, unfortunately, I still can't find a way to get around that. So, if anyone knows how to do it, please let me know. I would love you forever. theoretically. I mean, and yeah, that's that. Now notice again, this is showing factors, not the prime factors. Prime factors in this case would be numbers like 3, 37. Pretty sure 111 is not a factor. I can look it up right now actually if I really wanted to, but I just don't feel like it. 333 is clearly not, because you can just factor that into 3 and 11, 3 and 111 right there. You can see the pattern pretty easily right there. 1369, a pretty neat number, right? 369 multiples of 3, and the next number is 4107. Now, right now, I do not know if that's a prime number off the top of my head. Same thing for this 1369, so I'll let that be. Basically, it's just like a very basic video on the programs so far on this, and this, like I said, math paper, it's just a bunch of math trying to do a general formula or algorithm, whatever fancy way you want to describe it, to find prime number given any number and see if it's prime or not. And then if it is prime, fine, print it. If not, find the prime values that make it, kind of a thing. Now, this is another program I'm trying to do, which is so I can do it repeatedly. That way I can do this, then I would be able to do it again at the same time. I don't have to keep doing this. All I'd have to do is say Y or capital Y or yes or capital Y, yes, things like that. And then this over here, this prime number database, as you can see, there's a lot of numbers. And if you notice, you'll actually, oh, I just realized that. And you'll notice here that these are all numbers that are prime. So I'm not sure if you can tell, but I actually forgot to put the 800 and the 200s. I mean the 100s. So I'm gonna quickly do that. So let's make it nice and simple. Just copy and paste. And before I forget, let's get some do something nice here. Get a little nice twist, right? Okay, now all that's left is this. Now, just to quickly give you guys an idea of how massive this long list can be. This is it. It's all of these bad boys right there. All of that. No, this is so it's just a long list of first 1,000 primes. I'm not going to do the last because there's no such thing as last. It's been proven that there's an infinite number of primes. So I'll let that go. Now that was that. Let's continue to copy. Where's that music going? In case you didn't realize, this music is trailer music. I like my trailer music, it's fun. At least I enjoy it. Anyways. Where did you go? Okay, so 800. Okay, so let's look at some patterns here. There's, according to what I saw on another page, first 100 primes. Ah, yes, here it is. So, first 100 primes basically goes up to the 541 mark. According to this is 25 numbers. So that makes this to 199. Let's see, that's 1, 2, 3, 4, 21 numbers. So 25, 21, yeah, it's to about 541. So 541, this is first 100 numbers. 25, 21, that's something, and then right there, 100th. Okay, and there you have that. That's stuff. Okay, that's that, and I will see you guys later.